Alright, so hello and welcome to another part of this tutorial on C. My name is Rohit Das, and last time we discussed about data types and variables. I'd like to catch up on some things that I had missed out because we ran out of time. So it's about variables, what is variable declaration, what is variable definition, and what is variable initialization. Alright, so let's erase all this. Alright, so like we said in the earlier video, a variable is an allocation of space in memory. Now how much space will be allocated depends on the data type. Alright, but to start working with a variable, we first have to define a variable and then declare it and finally initialize the variable. So what do I mean? So commonly what we use is that we normally declare the variable and initialize it all together, or we can do it separately. For example, this is variable declaration. Alright, so here I am telling the compiler that I will be needing you to allocate a certain portion of the memory, that's 8 bytes, and that will be pointed by A. Alright, sorry, that's variable definition. Right, just made a small mistake here. So we define the variable. Defining a variable means telling the compiler to allocate some memory to it, and then we can initialize the variable with some value, let's say 12, since it is an integer. So this is called variable initialization. Alright, so basically what I'm telling the compiler is that the memory which you had allocated earlier, you have to store the number 12 in that memory. Alright, and compiler will actually check whether this is compatible with the data type that was actually declared earlier. Alright, and if it's not, an error will be thrown, or you can typecast it and make it into an integer, and the compiler will round it off. Alright, so let's check all those out. So like I said earlier, to print an integer you have to use %d, and let's see what happens. Alright, so here we see that we are printing 12. Now what happens if we make it into a floating point number? Let's see, 12.0. Right, let's save that. Okay, so it actually automatically typecasts the number into integer. Now what happens if I typecast this forcibly into a double? Okay, that works too. Alright, so basically what will happen is that even if it's a floating point number, compiler will store the number as an integer in it. And what if it's a number like this? Alright, so right, so as you can see is that the compiler stores the number in A and simply omits the part after the decimal point. Alright, so I was a bit wrong over there too. Okay, alright, so I hope it's clear what's variable definition and what is variable initialization. I spoke about another thing called variable declaration, which is done like this: extern int A. It's written, the extern keyword is needed to be written because the variable is being declared. Alright, this is declaration, it's the same thing as this, so no need to put an extern over here. You can simply define the variable inside the function or simply outside the function. If it's defined outside the function, it actually becomes a global variable where the value will be available to all functions throughout the program. Whereas if the variable is written inside the function, the value will be available only inside the function. We will be talking about scopes and visibility later, and there we shall know what I am talking about. Alright. Okay, so today we are going to move on to constants and operators. Alright. So constants are basically numbers which can be stored. Like integer constants are any integer number, either negative or positive. Alright. And for people who don't know what's the base or radix of a number, let me talk about that a bit. The radix of a number means that how many symbols or how many digits are available to represent a number in a particular radix. Like suppose we have the decimal number system which has the digits 0 to 9 to represent any kind of number. So the radix is the number of digits that are present in the system. So since we have 10 digits in the decimal system, 0 to 9, so decimal system has a radix of 10. We also call it as base, so it's base 10. A hexadecimal system will have a base of 16. It contains digits from 0 to 9 and A to F. So it goes 0 through 9 and then A through F. So that's 16 digits. And then we have the octal system where there are 8 numbers, 0 to 7. And finally we have the binary system that we are all acquainted with. The binary system contains 2 numbers and hence has a base of 2. Alright. So whereas we can't store binary numbers exactly in a binary format, since this whole code gets converted into machine code, that's binary numbers eventually, what we can do is that we can store octal and hexadecimal numbers here. Alright. So let's see how that is possible. So for here I have done int a and then I've written a equal to 12. Alright, so let's make that in one line so it's better to understand, easier to understand. Alright. Alright, so here we have simply stored a decimal number. Alright, now what if we want to store an octal number? So to store an octal number we just have to put leading 0 in front of 12. Alright, and that will be stored as octal. Now to check whether this number is stored as octal, we have to use a number greater than 8, and as you can see it is giving an error because 8 does not exist in octal decimal system. But let's try to print that anyway. As you can see it gives an error telling that 8 is an error, it's not a valid octal constant, whereas if I use 7, that's fine. Alright, now you may be confused that why is it printing 15 when I'm writing 17 over there. Well, actually since I've used D, it will print it in decimal format. Alright, it will change the number to decimal and print it so 17 in octal is actually 15 in decimal. If you check that, you'll know that. Alright, and let's see how to store something in hexadecimal. So for octal you use a leading 0, and for hexadecimal simply put an X after the 0. Alright, like this. Now let's use that 15 in decimal again. Alright, now let's see what happens. Maybe did I see something different? I think. Wait just a minute, let me check. Alright, let me just confirm. I won't want to give you the wrong information. Alright, let's see. If the octal is 17, what's the decimal? Alright, so as you can see over here, it actually gave us the decimal output as always. And for hexadecimal, let's see what happens. on change it, yeah, hexadecimal converter. Alright, so let's use 17. What happens? No, did I get 17? I get 15, right? So as you can see over here, we have used 15 as the hexadecimal number in our program, and the output is 21. So the output is always in decimal. Alright. Now what if we want to get the input in that particular format? Is that possible? Yeah. So if you want to get the output as it is, you can use the %x sign, which will output the number just like as it is. So if you want to use the hexadecimal, you can just simply use x and it will print the exact hexadecimal number. Or let's take a, for example. It will be much clearer with that, how it works. Alright, so it prints a small a. Okay, so here the small a and small b is the same thing. So let's see, small a and capital A in hexadecimal. Alright, so as you can see over it just prints in small letters. Alright, so if you use capital X, it will print it in capital letters. If you use small x, it will print it in small letters. In case of octal, let's see what happens. It will print the number in octal. Alright, so okay, so capital X is actually printing it in hexadecimal. So is there a O there? Alright, so if you use %O, it will print the number in octal. So even if you don't use a leading 0, compiler will read it to be a decimal, and then the output will be directly changed to octal. So previously when we had used a leading 0, the output was 17. Now the leading 0 is gone. So now 17 has become a decimal instead of an octal. And now let's see what the output is. That's 21. So as you can see, we can fiddle with various data types and formats in which we can store constants in variables, and we can get the desired outputs. So let's recap that. If we want to store an octal, we have to use a leading 0 like this. And to print an octal in octal format, you have to use %O or %O. To print it in decimal format, we will use a D as usual. And if you want to store something in hexadecimal format, we will be using 0x, leading 0x, and using the placeholder x, %x or %X, whatever, and it will print it in hexadecimal format. Same rule goes to print it in decimal format. Alright. So these are called integer constants or integer literals. Constants are often called literals as well. Alright. Okay. So there is another thing I want to say. If you want to store an unsigned number in a signed variable, you can use the literal u that tells the compiler that 17 is unsigned. Alright, so let's see what happens if we put a negative number and a u after that. Alright, so the minus is getting printed if we put it in a bracket. Alright, so as you can see, it's giving an error telling that something is expected before u, so it's reading u as a variable. Alright. Alright, so there's no way to represent that it's actually storing it in unsigned format, right? But never mind, that's how you do it. And if you want to store it in long format, you can do that as well using capital L. Alright. Okay, as you can see over here, actually if you use u over here and then use u, you can actually print it in unsigned form. So now as you can see over here, while we use %d, it will print in decimal form, but since I used u, %u, now the compiler is trying to print -2 in unsigned format, and look what just happened. The number got wrapped around like we had studied before. If we tried to store a negative number inside an unsigned variable, the number got wrapped while printing it. A similar thing has happened right now. We stored an unsigned number. -2 is not unsigned actually, but I'm indicating that that should be an unsigned number, and that is being stored in an integer variable. Now when I try to print it as unsigned, compiler wraps up, or the function, the printf, wraps around the number and prints it. Alright, but if you use %d, it will be printed as it is. Okay. Alright, so next we have floating point literals. Now floating point literals can be printed in various formats. Alright, you can either use the normal floating point representation, or you may use the scientific notation, which is printing something in powers of 10. Let's check that out. Let's see. So I can either print something like 2.6, no, let's say 3.1419 something. Alright, and let's say I'm trying to print the next up to 10 digits of the decimal, after the decimal. Alright, so let's see what happens. That compiles. Let's clear the screen a bit. Alright, so as you can see over here, the number has been filled up with empty zeros. Right, so that's how you can either do it in this format, or one more thing you can do is that, like I said, you can use the scientific notation. Now the scientific notation is used as follows. The decimal is there, let's see, and then you put either a capital E or a small e, it's the same thing, and then you put the power. Alright, so the power will be -4, I believe. Alright, so as you can see, it's back to a constant, or you can use a capital E as well, it's the same thing. Now let's see what happens. What does it print? So as you can see over here, it prints the same thing as we had done before. Alright, next we have character constants or character literals, which are nothing but characters. Right, so we store characters in a char array, or like I said, we can store it, not a char array, sorry, a char variable, or we can store it in an integer variable and use %c over here to print it in character format. We'll look into that later. So let's say we have a, and we try to print that. It prints a. Now what if we try to print it in decimal? Alright, it prints the ASCII value of the character stored in it. We can also store a character in an integer variable. Right, and let's see what happens. Simply stores the ASCII value. Alright, so I hope this is clear about the concepts about constants. I hope I'm not going too fast, because these are very minor concepts in C, which we shall just glance over before we move on to the more important bits like conditions and iterations. Alright, and then we have string constants. Now how do we use string constants? We'll look into that later. Alright, but for now, a string constant basically is a set of characters enclosed with double quotes, and by default C ends a string with a null character to show end of string. Alright, the string is not, the null is not visible, but it is there. It is stored in memory in that format. A string, when a string is stored in memory, it will contain a null pointer, I mean a null character to indicate the end of the string. Alright, so I'll be showing how to, okay, let me just show for now how you can store a string. So you use a char star, and let's say I'm trying to print Rohit, and then this will be %s. Let's see what happens. Alright, so you can store a string using char star and followed by the variable storing the string, right? So this is containing 5 characters, so let's try to print the 5th character. Let's see what happens. But argument is type int. Okay, since it is one character, we have to use %c. Okay, sorry about that. Okay, now the program should run. Alright, so as you can see over, it is not giving an error, but it is also not printing anything. So this clearly shows that the string is ending with a null character. Now let's make it 6 and see what happens. Alright, so as you can see over, there's nothing more to print, that's why it's printing nothing. Alright, so this is how you can check things. Okay, so today we have for now we have covered constants, integer, floating, character and string literals. There's another way we can use constants in C. Let's show that. There's a way of using constants in C using hash define. Right, so what hash define? These are actually macros in C. We will be talking elaborately about macros later, but for now I'm just telling you how to use constants. Like suppose in our program we need to use the value pi a lot of times, but suppose we can't remember the value pi all the time. So what we can do is that we can simply define a variable inside. We'll come to that. Also we can also define a macro. Alright, so hash define, that's called a macro, and let me show you how it's done. So first we write hash define, and then we write the word which will replace the value, and then 3.14159 whatever. Alright, and now if we try and print that, let's see what happens. Right, it's a decimal, I mean a floating point. Right, so as you can see over here, it by default it prints up to 6 digits after the decimal. We can restrict it like I have told before, and this is how we can define a constant outside the function which will be available in all functions throughout the program. Right, whereas if we can also use constants like this, const pi equal to 3.14159 semicolon. Right, okay, should it be a double? Yeah, I forgot to define the data type as well. Silly me. Alright, so that's another way you can declare constants in C. We can either use hash define macros, or we can use the constant keyword in front of the normal variable definition in C, either inside the function or outside. So this I've done inside the function, which will be available to other functions as well, whereas I can use a constant over here and then try to print that. Alright, so why use constants? It's basically because we can't change the value during the execution. Let me show an example. Alright, so let's see how constants work. Right, so let's make this into int so that we have ease in calculation. Let's make it 45, and let's try to increase the value of the variable during execution. And then try to print the thing again. Right, so as you can see over here, it says that it gives us an error saying assignment of read-only variable a. So the variable a has become read-only or a constant. So I hope that's clear to you what constant is. Next we shall talk about operators a bit. So there are basic operators in C for like addition, subtraction, multiplication and division. Then there are the increment operators. This bit there. So we change this. Alright, so we have increment operators and decrement operators. Increment operators look like this. This is the same as writing this. Alright, so this is an increment operator, and this is a decrement operator. Alright, you can either write it before or after, but they are not the same. Alright, so how they are not the same, let me demonstrate. So initially we have a equal to 45, and let me use this, the plus after, two plus signs after the variable. So this is called post increment operator. Alright, so what it does is it first uses the value and then increases it by 1. Alright, so let's print that and see what happens. Oh, right. Okay. So one thing I'd like to tell you is that whenever you write a program and compile it, do not ignore the warnings as well. You can ignore the warnings and run the program, but then that wouldn't be a very good program. So a rule of thumb should be to try and remove all errors and warnings before finally running the program. Alright, so as you can see over here, initially a was 45, and then after this step it has changed to 46. Okay, now if we do the pre-increment operator, it will be the same thing, right? So both of them increase a by 1, but we can't understand the difference very clearly over here. Alright, so let's take another variable over here, int b equal to 0. Okay, so what I'm going to do is that I will be assigning b equal to a plus plus, and then I'll be printing it as well, the comma, we have a b, and then we have a b over here. Okay, so that will be a much clearer example. Alright, so as you can see over here, initially a was 45, b was 0, and next a got 46 but b got 45. So here you can understand that first b was initialized with the initial value of a. So initially a was storing 45, so that value got assigned to b, and after the assignment a was incremented. So that's why we have this. But if we use the pre-increment operator, let's see what happens. You have to be careful with these, right? You got to know very clearly what does what. Alright, so now you can see that a got incremented first and then it was assigned to b. So now I hope you understand what's the difference between the post increment and pre increment operators. It's the same thing with the decrement operators as well. So a will be increased first and then it will be assigned, and if you use the post decrement, I'm sorry, and then a will be assigned first and then it will be decreased, right? So I hope this was clear. Next we have a few kind of operators. So now these are basically increasing or decreasing the variable by 1. Alright, so what if we want to increase or decrease it by n? Alright, so let's see, say b is 2. Alright, so and I want to decrease a by b. So instead of doing a equal to a minus b, what I can do is that I can simply write a minus equal to b. So this is the same as writing a equal to a minus b. Alright, we can do this with basically any kind of operators. We can do it with plus, we can do it with multiplication, with division, with modulo. So what basically happens, this operation simply gets replaced. Alright, so I'm writing it as a op equal to b, where op equal to plus, minus, star, slash, modulo. Alright, so these are all the normal arithmetic operators. Modulo is the modulo operator, which basically gives us the remainder of the division of a and b. Right, so this is how we can shorten code as well. Okay, so these are arithmetic operators which work with arithmetic. Next we have the relational operators and the bitwise operators, about which we shall be talking in the next episode. Right, there is a bit of explaining to do about those operators. They are not as easy as arithmetic operators. For those who know about how bitwise operators work, they won't have much problem, but for the rest it will take some time, and I will explain it gradually and slowly so that you can understand. Alright, so hope you guys like this video. Leave a like, comment, subscribe, and see you guys in the next video.